Welcome to this video about the normal distribution. It's about the bakery which makes products with a certain weight, and this weight is not the same for every bread. And why is that? Well, because there are ingredients in it which are natural and the process is not controlled in such a way that all the weights are the same. Now let's analyze this distribution, and we presume that this is a normal distribution. Let's go to the case. Now, in order to define a normal distribution, I need an average and a standard deviation. So what are these measures? Well, I prepared a small data set and I'm going to unhide it now. And this is a sample of 1000 pieces, and I'm going to research what are the characteristics of this data set. I'm going to unhide another column, and I want to count how many numbers I have, what's the average and the standard deviation. Well, let's first make the count function equals count, and counts the number of cells in a range that contains numbers, tab. Now I can select this range, but this is quite difficult. It's easier to select the whole column. So you see only the column name O to R. Bracket close, enter, and you see that there are 1000 pieces, 1000 numbers. Now what's the average? Equals average, and the average tab, I repeat this, the 4 columns, bracket close, enter. So this is almost 400. I will reduce the number of decimal places, and I presume this is 400. Well, what's the standard deviation? Equals standard deviation. And there are two. One is for the population and one is for the sample. The S stands for sample and the P for population. So I choose for the sample, tab, and I choose the 4 columns. Bracket close, enter. And this number is almost 12. So what I do now is that I presume that the average weight is 400 and the standard deviation is 12. Actually, this is my input value, and that's why it has these colors that you see this here. Excel has some Excel styles, and one of them is input and one of them is calculation, and we used these values as input values for our model. Now, how does a model work? It's a distribution, a normal distribution, and the Excel function is NORM.DIST in the English version. Let's try to enter this formula by hand. Equals normal distribution. Do we found it already? Normal distribution returns the normal distribution for the specified mean and the standard deviation. That's what we want. Tab. The x values are the values for the certain weights. Now, it's about 400, so 400 is in the middle. There are breads which are below, and there are breads which are above it. And we make a guess that these are relevant numbers. So this is the x value. Now, what is the mean? The mean is the average, so 400. We are going to copy it down, so we fix it with the F4 button, so we have the dollar signs to it. Semicolon. The standard deviation is 12. F4 to lock it, and then cumulative. Well, there are two options: true, the cumulative distribution function, and false, the probability mass function. If you are not an expert in statistics, it might be difficult to remember this or to learn this by head. So in this case, I'm going to try both of them, and later on I will see which one I use. So we have two options, true and false. I entered already the word true and false in C7 and D7. So let's start with true. Tab, bracket close, enter. I copy this down and I see some numbers in it. Now I repeated this for false. Equals normal distribution. The x value is the weight. The mean is the 400. F4 to lock it. The standard deviation is 12. C3, F4 to lock it. And then cumulative is false. Bracket close, enter. Now copy it down, double click and send it down. Alright, let's make a graph of it. We make two graphs, one true and one false, and then we compare the two graphs. First, we're going to do this one. And what kind of graph do we need? Well, we need a XI diagram, and we are going to combine the dots. Now, insert graphs. This is a chatter diagram, an XY diagram. And we choose for this one because it has some smooth lines, a scatter with smooth lines and markers. Or no, we don't take the markers, we just take a smooth line. So select it, and we have this version here. And this is the version of the true. Right, it starts at 0, and this is not very clever. Maybe we start with 350 and return to 450. So we are going to change this. The axis, we are going to click and set the minimum value at 350 and the maximum value at 450. Now we see then that this is white, so this is manually adjusted. And the major unit here, we put it on 10. I think this is a better value to see this. And we have more numbers to it. Okay, so this is true. And the maximum value I put here at 1. So double click. And then I see for the axis options that the maximum value is 1. And the minimum value is 0. Now I'm going to copy this. Control C. Click here somewhere else. Control V. What I'm going to do now is I'm just going to use the X values, but the I values, I just select the range and move it aside. So the numbers are different. Here is true, I change this to false. Now, what you see here is that this number is totally wrong because it's too low. Now we have to change the axis, and the minimum we put on auto, so we will set this maximum value. And then we see something which looks like a normal distribution as we've seen in our theory books. So we have two graphs, one is false and one is true. Let's continue. In statistics, this axis here is not relevant. We only want to see the shape, and the number, the absolute height, is not relevant, so we are going to delete just this axis. So select the axis and press the delete button on your keyboard. To see what happens with the shape of this bell graph, we decrease the standard deviation to 2, and the other value will remain. So the 400 remains, and what we see then is some kind of an other distribution. Now put it back into 12 as we had it before. Now what does it mean? Well, the false values which are here are not relevant. So the absolute height is not relevant. The only reason why we need it is to construct the shape form, the bell graph. What you see here is a density function. So if you put a value of 400, then the surface to the left side is the same as the surface to the right side, and this is actually 50%. So that means that when you produce a bread, the chance that it's less than 400 is 50%, and the chance that it's more than 400 is also 50%. And we see this in the graph on top as well. If you have a bread of 400, then you go up, and then you see that the chance of having a bread below this value is 0.5. If you have a bread of a number of 380 and you want to calculate how many breads or what is the percentage of bread below this value, then you need to calculate the surface of this area here. Now what is the surface of this area? We look at the graph above. You see 380, and then you look into in this line, and this is the value 0.048, and this is exactly the value which is also here in this table. So now we can calculate some values of it. Let's make some space. and see what the chances is. The percentage of breads below, well, let's say 390, or the percentage of breads above 430. Let's make the calculation. So 390, it is this value, of course. We know that this is already the case, so about 20%, but let's calculate it again. Equals standard deviation, normal distribution. The x value is 319, the mean is 400, the standard deviation is 12, and cumulative is true. So in order to have this, it's the cumulative distribution function. Bracket close, enter. So we see that we have a 20%, let's format it as a percentage, 20% chance that the breads are below 390. Now, let's repeat it for 430. Well, we cannot calculate directly what is the chance that it is above, but we can calculate what is the chance that it's below 430. So the answer is 1 minus normal distribution. The x value is 430. The mean is 400. The standard deviation is 12. And we need true because we need this function. Bracket close, enter. Now repeat it here as a percentage. Oh, it's very low. It's 0.6% that a bread is above 430. Well, I change it to 420. Let's see what happens. 420. We have 4.8%. Alright, this is the normal distribution, and in this way you can make some calculations. What is the chance that the breads are between a certain range? So, what is the chance that breads are in between? Well, this is easy. We can make insert and make a line, shapes a line. So the first line was 319. Let's make a line here. This way. And the other line was, let's make a line, 420. Alright, so we can calculate what is the surface of this graph between 319 and 420. Well, this is the percentage. Below 319 it's 20%. Above 420 is 4.8. The total surface is 100%. So we can calculate between equals 1 minus 20% minus 4.8%, and 75% of all the values are between those borders. Well, this is our, of course, calculations, so we make a calculation of it. And the calculation here, and to be very precise, this value is an input value and this is an input value. Now, if I change these borders here, then I have other values. So the 70% is the percentage between borders. Thank you. I hope you liked this video about the bread and the normal distribution. Please learn it not by head, true and false, what it means, but just make those two graphs and see the difference and the relations between those two graphs. Thank you very much. I hope you enjoyed the video. See you next time. Bye bye.